All right, you need to have out your periodic table, your notes, and your lab that you picked up as you came in. We'll go back to the quiz after we finish, and I'll come around and get numbers depending on if you got finished or not. Today we are going to learn about how to write elements, diatomics, and writing and balancing chemical equations, and predicting precipitates, which are solids. You're going to upload your daily work. Daily work basically today is the notes from today. So make sure your name is on every page that you upload, because I've had to give people zeros because they forgot to put their names on them. So make sure your names are on them. Most of the bulk of today is going to be working on a pre-lab, general precipitation reactions, the formation of a solid, so that you can do the lab next time. So first up in your notes, what do you do when it's just an element? In an equation, you just write it. Use the symbol, okay? Unless it's a diatomic. So what's a diatomic? Diatomics are molecules that are like Siamese twins. So they stick together. Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. These are elements that are ones that stick together when they're by themselves. But if they're put into a compound, they take the charges that we want them to. I worked for a long time with another guy that he said, oh, it's easy to remember. It's Bronhifkel. She's my Russian girlfriend. So it stuck with me. I don't know why, but Bronhifkel stuck with me. It had a way to remember it. You can also remember it by upside down L here, this purple area, NOFClBri. That upside down L and hydrogen are the ones that make diatomics. Yes? Ones that they stick together like Siamese twins. So there's two of the same thing. So what are the diatomic molecules? And then we've got these that are the diatomics. So Br2, O2, N2, H2, I2, F2, and Cl2. Okay? We also have two other elements that like to hang around in multiples. So they're like multiple births. Okay? So you have the twins, they're more common. But then you have phosphorus, which is a quad, and sulfur, which is an octet, which is very less common. But sulfur does like to hang around like that. Phosphorus, you can see it's in a triangle. There's actually 3 types of phosphorus, white, red, and black phosphorus, and they all react differently. Sulfur tends to, it's almost like a chair thing, but it's 8, and it goes up and down around. And they actually sit on top of each other, and we make vulcanized rubber and stuff because of that. So these are ones that we're going to need to know. They are only this way when they're by themselves. So if it said and sulfur, then I would say S8. But if it says sulfur dioxide, I wouldn't write S8O2. I would just write SO2. Okay? So if it's in a compound, it takes a charge like we normally would do. All right, so this is refresher. So aluminum hydroxide plus sodium nitrate yields aluminum nitrate and sodium hydroxide. This is what I do when I come up to these things. I say, okay, what's aluminum? Al. What charge does Al have? That's part of the slide. Look at where Al is. If you haven't got your periodic table out, you're going to need it. What charge did Al have? 3. Good. It's part of the slide. So boron, aluminum, and gallium +3, zinc +2, silver +1. Then I look at the next one, hydroxide. Oh, that's one of the ones that Mrs. Howell told me I was on the back, but it has an IDE ending. Remember, cyanide and hydroxide. So what was hydroxide? OH with a -1, right? Then I go and I say, okay, I'm going to make this together because the next thing is a plus. So I know at a plus I've got to stop and I've got to make these go together. So if it's +3 and -1, how many of each do I need? So they add to 0. How many aluminums do I need? I need 1 aluminum because it has a +3 charge, but I need 3 -1s, right, to cancel out the aluminum. So I need 3 of the OH groups, and since it's the group, I put it into parentheses. Then I go on to the next one. It's sodium. What's sodium? Na. What charge does Na have? What column is it in? First one, so it's a +1. Okay, nitrate. 8 is on the back, so look on the back for nitrate. Good. NO3 with a -1. Oh, +1, -1. I just smash them together. So I put plus NaNO3. I leave myself some room because I know I'm going to need to balance later. Now, once I get to the arrow where it says yields, I've written all the ions I need for both sides. I just need to put them together differently on the other side. Oh, couple, couple. What am I going to get on the other side? This is back to types from last time. Couple, couple. I had 2 couples up here. Then what happened? I double displaced them. I got 2 new couples over here, right? Okay, so the other side says yields aluminum nitrate. So aluminum and nitrate are going to go together. You always write your positive first. So aluminum has a +3. Nitrate has a -1. How many of each do I need? 1 aluminum and 3 nitrate. So I need to put nitrate in parentheses with the 3 on the outside. Then I get another plus. Then it's sodium with hydroxide, right? Well, +1, -1. Remember, I always write my positives first. So NaOH. Okay, is it balanced? Side to side, is it balanced? No. Okay, so here's a trick. If the polyatomic stays together on both sides, I can just look at the polyatomic and treat it like an element and balance it that way. So I have 1 aluminum, 3 hydroxides on the reactant side, and only 1 hydroxide on this side. So I'm going to put a 3 right here. So I have 3. Now I have 3 sodiums, only 1 sodium. Put a 3. I have 3 nitrates, and I'm done. Okay? So this is a double displacement, and we've gone through how to write it from beginning to end. Okay, so you need to be able to tell me what type it is, be able to write each individual compound, and then balance both sides. Okay? Let's go on to the next one. Next one says iron metal. What's iron? Fe. Okay, well they gave me Fe, but then they said metal. What do you think that means? Just iron by itself. It is a solid by itself, right? So then it says plus copper, Roman numeral 2, sulfate. Okay, so what's copper symbol? Cu. What's that Roman numeral tell me? It's the charge, right, on copper. So this 2 refers to the charge of copper. What's sulfate? It's on the back because it's got... Good. SO4, 2 negative. So I got +2 and a -2. I'm just going to smash them together. Cu, SO4. Hasn't told me what it is, so I'm not going to tell what it is. It's probably aqueous, but we'll go on. The next one says yields iron, Roman numeral 2. So remembering that that's my charge, and iron is a 2+. And then it says sulfate again. So this time I'm putting these 2 together. So Fe +2, SO4 -2. I'm just going to smash them. And then I have copper metal. What do you think I'm going to put for that? Just Cu. But I'm also going to say it's a solid because it's a metal. What metal is the only metal that is not a solid at room temperature? Yes? Mercury, yep. Okay, is this balanced? Is that balanced? Yeah, it is. What type of reaction is this one? Single displacement, because I have an element by itself plus a compound gives me a new compound and a new element by itself. Okay, so let's go on to the next one. Potassium, what's that? K, what charge does K have? +1 because it's in the first column. Bromide, what's that? Br, what charge does Br have? Minus. Okay, so it's just smash them together, right? KBr, oh, already yields. Okay. Potassium metal, what am I going to write? Potassium, which is a K, and then the S to say it's a metal, plus bromine gas. Careful. Br2. It's part of Braunhifkel. So Br2, and it's a gas, they told me, so I'm going to do subscript with a G. Is it balanced? What do I need to do to fix it so it is balanced? Where do I put them? Good. All right, so now it's balanced. What type of reaction is this? Yep, decomposition is right. It's falling apart. So one thing falling apart. So I left the posters up here so you can look at them if you need to. All right, we're going to watch a little video here. And while we watch the video, I want you on the back of your green paper, if you've got enough room, if not on the back, on the front, you're going to take some notes on this. Make sure you put your name on it. So what we've just done and this green paper are what you're going to submit for today's daily work. Okay? Make sure you take some good notes because we're going to be using it. Okay? Yep.
Hi everyone, in this video I'm going to teach you how to learn your solubility rules really easily, and my name's Shilpa. So the way I remember solubility rules is to think of someone sagging his or her pants. Please never sag your pants. Nobody appreciates it, and we'd much rather not see you like that. But anyways, this mnemonic does come in handy, and this image does come in handy when you need to learn solubility in chemistry. So the way to remember all the molecules or substances that are always soluble, you think of NAGSAG. Always soluble elements. NAGSAG, I mean molecules. So the way to remember NAGSAG is to remember that whenever you sag your pants, somebody's going to nag you. So the N in NAGSAG stands for nitrates, NO3 minus, the A for acetates, C2H3O2 minus, and G for group 1, the group 1 metals such as lithium and sodium, and many more. S is for sulfates, which is SO4 minus 2. A is for ammonium, NH4 plus. And lastly, of all the soluble ones, group 17 nonmetals, such as fluorine, chlorine, bromine, iodine, and more. Even though I told you that these elements and molecules are always soluble, I lied, because there are two specific groups that are exceptions. Now, the very first group I like to call PMS, and it's very easy to remember, just 3 letters. And the P stands for Pb plus 2, which is lead. The M stands for mercury, diatomic mercury, Hg2 plus 2. The S for silver, Ag plus. And the second exception, or before I go on to the second exception, I'm just going to make things easier for you and put a nice magenta asterisk next to PMS, and then put a magenta asterisk next to the sulfates and group 17 nonmetals, because PMS is never soluble with the sulfates or the group 17 nonmetals. Now let's move on to the second and final exception. This exception is called castor-ware. Castor-ware. And castor-ware, the reason it's given that name is because it's calcium, strontium, and barium, all from the alkaline earth metal group. And castor-ware is never soluble with sulfates. So you see that beautiful neon green asterisk next to castor-ware? Well, we're also going to put one next to the sulfates because it's never soluble with the sulfates. And I suppose since now we know two exceptions to NAGSAG, NAGSAG is not always soluble, but it's almost always soluble. Good luck.
Okay, I'm going to leave it there for a minute because I know some of you were writing as fast as you could and still couldn't do it. So we're going to let it go there for a minute and see what you can come up with. Okay, give you about another minute. Okay, let's see what we can do here. All right, if you get your lab out in front of you and have this green sheet open so you can sort of see what's going on. We're going to do some of the lab together so you have some good examples. Okay? Okay, before we get into there, we're going to talk just for a second. How many have had math and you've talked about FOIL in math? A little bit. So, you know, first, outside inners last. Okay? Well, in chemistry, we use OI. Okay? Sort of like OI. We use outsides and insides, and I showed you that on the first one, but I didn't tell you what I was doing. But that's what we were doing. We're going to use that and help us to be able to figure out what the products should be. Okay? So this is your lab that we're going to be working with. You're going to be mixing solutions, which are aqueous. So anything on your reactant side is going to have the little AQ. You're going to try and figure out what your products are. Which ones are going to stay in solution, which ones are going to fall out. The ones that fall out are called precipitates, and we call them solids. The ones that stay in solution we'll call aqueous. So we're going to go through each of this. This is what I do, just like what we were doing before. I read each one and write what it is above it. So sodium is what? Na, what charge? +1. Okay, carbonate. Look at the back of your periodic table. I keep bugging you. Good. CO3, 2 negative. Good. And then there's a plus. So I'm going to stop right there and I'm going to put those two together. How many of each do I need so that it will add to a 0 overall charge? 2 NAs. Okay, so I'm going to go Na subscript 2 CO3. And what did I tell you about everything on this side? All the reactants are AQ. So I'm going to put a little AQ there and then put the plus. The next thing is silver. What's silver? AG. What charge? Just a +1, right? It's the bottom of the slide. Nitrate. Yes? Okay. It's okay. Nitrate. That's on the back of your thing too. It's NO3 with a minus. So we have a +1 and minus what? We're just going to smash them together. AgNO3. And this one is also AQ. Then we hit the yields. Once we hit the yields, we don't have to write any more ions because we've got all the ions we're going to use because of the conservation of mass. Right? What I have on the reactant side has to be on the product side. So this is when I can do the OI, outsides and insides. So if I look at the outsides here, sodium and nitrate are going to come together right here to make sodium nitrate. Right? +1, -1, just smash them together. So NaNO3. Now I need to figure out, is it a solid or is it aqueous? So I go back to my rules. NAG. Nitrates. Yeah, it's there. Because nitrates are there, it's soluble. I don't have to go any farther. But this one also has group 1 metals, which is the G on NAG. So this one is aqueous because it is soluble. Okay? Plus, now I'm going to put the insides together. Remember, we always start with our positive and go to the negative. So we have an Ag that's a +1, carbonate that's a -2. How many of each do I need? 2 Ags and a carbonate. So I go down my list, NAGSAC. Nitrates, no. Is it ammonia or, no, it's acetates first. Acetates, no. Group 1 metals, no. SAG, sulfates, no. Ammonia, no. Group 17 metals, no. So I had no, 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 no. Because I was no, 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 this is a solid, or what I will see hopefully as a solid. Now, this all depends on how concentrated things are in solution. If I have just a little teeny bit of lead in a lot of water, when I go and put it together with chlorine, it's not going to come out as lead chloride. Okay? Because they're too far apart. It's like trying to get somebody to date in Lima, Montana, graduating class of 6, together with somebody here. Okay? It's going to take a lot of effort to get those two together. Okay? All right, so is this balanced? That's the next thing I need to do. Because we're going to write the equation, find out if it's balanced. Okay, what do I need to do to balance it? 2 what? NaNO3s, okay, what else? 2 Ag what? Which one? NO3, okay. All right, if you still need to bump that scratch piece of paper up, do that. There's going to be some that are going to be a little bit hard to balance. Remember, if you have a 2 on one side and a 3 on the other side, what's the common factor you want to get to? 6. So you'll need to put a 3 in front of this one and a 2 in front of this one. So the second one right here wants you to write what the solid is, or what you should see as a solid. So in that reaction, if something falls out, what is it? Silver carbonate. So I go Ag2CO3 as a solid. Now, we're going to make a master list of all, because we're going to go back and we're going to do a grid system, and we're going to go drop, 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 and go drop across. So if you go to the very back of these that look like this, there's a small grid. There's a big grid that we're going to use back in lab, but there's also a small grid. Would you find that small table grid? It's on the second to last page at the bottom. It's really small. It has silver nitrate in one column, lead nitrate in another column, and calcium chloride in the last column. And it's just the small one down at the bottom of the page. You found it? Not the big one. The big one we're going to use back in lab. So we just combined silver nitrate, which is in the first column, with sodium carbonate, which is in the first row, right? And what did we end up thinking we're going to get as a solid? Silver carbonate. Write that in that blank box right there. First row, first column, box. So Ag2CO3. So if I get a solid, that's what the solid is. So I can now explain what it looks like. Carbonate, Ag2CO3. Okay, so let's go back. We're not going to go right in order, so I'd like you to find F. We're going to do F. So find F. Okay, we've got sodium carbonate again, so we're going to do Na plus and CO3, 2 minus. That's what we did on the last one, and we put it together to make Na2 CO3, and we know it's aqueous because we're mixing 2 liquids, plus the next thing says lead Roman numeral 2, which means what? Plus 2 charge on lead. Good. Pb 2 plus. What was nitrate? We had that before. Do you remember? NO3 minus. Good. NO3 minus. Okay, I got to put those together so they'll add to equal 0. How many of each do I need? Good. 1 lead and 2 of the nitrates. And since nitrate is a group, I put it in parentheses. If it wasn't a group, I would not put it in parentheses if it was just an element. And this one is also AQ. It's going to yield, again, OI, outsides, sodium and nitrate. They're telling me here, right here. So I like to do this up above because I've already got the ions and I can see how they go together. So Na is a +1, nitrate's a -1. Hey, we looked up that one before. What was that? Was that AQ or was that an S? AQ, because it's part of NAGSAG, right? Okay, plus, then I'm going to put lead-2 and carbonate together. So +2 -2, I'm just going to smash those two together. PbCO3. All right, NAGSAG, nitrates, acetate, no. Group 1 metal, no. SAG, sulfates, ammonia, no. And group 17, no. So it's 6 no's, and that means it's going to be a solid. Is it balanced? It's not. Okay, what do I need to do to balance it? 2 NaNO3s? Is that it? That is it. That's all you needed to do because we have 1 lead on both sides. You have 1 carbon on both sides. You have 3 + 6, which is 9 oxygens on both sides, and 2 sodiums. Okay, so what's my solid? Is going to be my solid. So then I'm going to go in the back again to that grid and find where sodium carbonate and lead nitrate cross, and I'm going to put lead carbonate in that box. It should be the 2nd column, 1st row. Now, if you do these in order, it will go down 1 column and then come to the top of the next column, go down that column, go to the top of the next column, go down that column. So you should be able to follow it really. I just skipped around. Okay, so right here, you're just putting that formula in. Yeah, you don't have to put the name. No, just the formula. So you're going to go down that column from the very beginning, and then up to the top of the lead column, go down its column, and then you're going to come to the top of the calcium column and go down as you do them in order. Lead nitrate and sodium carb. So 2nd column, first row is where that one goes. Okay? All right, so you're going to be doing this for the rest of them. This is practicing everything that we've done so far. These are all what kind of reactions? Couple and a couple, new couple and a couple. Good, double displacement. So you're going to be practicing writing double displacements. You're going to practice your charges. You're going to practice balancing. You're going to be practicing your new skill, which is it soluble or not, right? So once you get that done, or if you have problems, let me know. I'll come help you. But once you get that done, you're going to come check it off with me and get your stamp. You have to have the stamp to be able to be allowed back in lab. Okay? This is what we're doing the rest of the period. So you just need to upload what we did for notes. That's today's daily work. And then this is your work right now in class. Okay? All right. Yes?
So you got this right here. Mm-hmm. So if it doesn't balance out, right there, then it's not soluble.
No, you have to put a 2 right here and a 2 right here. You have to balance the equation.
Okay.
What tells you if it's a solid or not is it part of this rule? If it's part of these rules, then it's soluble, meaning it's going to stay aqueous. If it's not, like the exceptions, or it's not on this list at all, then it's a solid.
Does that mean if it has lead in it, then it's always a solid?
Pretty much.
Okay.
Pretty much. The only time it's not is if it's a nitrate, because there's no exceptions. Nitrates or acetates, then you can get that to dissolve, or with chlorides it doesn't. So
if you have NO3 minus in your equation, then it's a solid?
No, NO3 minus is a liquid. So soluble means it stays as a liquid. So if I get salt, it's soluble in water. It means it's going to dissolve in water. That's what soluble means. Okay? All right. Yes, ma'am.
So from here.
Okay, what's this?
This is silver phosphate, right?
So you forgot the phosphate.
P is the same thing.
Well, you're putting silver and phosphate together, so silver's a plus 1. Right. So silver's a plus 1, phosphate's a minus 3, so how many of each do you need?
3.
But you still have to keep the PO4, because that's part of that group.
How do you find out if it's a soluble?
So then I say, okay, that's silver, there's no silver, that's phosphate, there's no phosphate, that must be my solid.
Okay.
That's all I'm doing. Then you need to make sure you balance side to side, and then you'll just bring this down here.
How do you find out if it's AQ?
AQ is if it follows one of these rules, it's going to be AQ. Like this had a nitrate in it, so that's why it was AQ. That had a nitrate, it was AQ. That had a sodium, which is right here, group 1 metals.
AQ means
Okay.
it's liquid.
Right. Think when you think AQ, think, yeah, aqua, like Spanish. Okay, let me stop the video and then I'll be right to you.